Hello, I'm John Manure from Accu-Slice. In a previous video, I demonstrated mounting the Accu-Wedge system directly to the bandsaw table without the use of the Accu-Slice system. This idea was generated because a customer asked about doing this. He didn't want to buy the Accu-Slice system just to make wedges for segmented wood turning. So it's something we hadn't done in the past, so I thought I'd go ahead and give it a try. And so what I did, I took my Accu-Wedge system and I mounted the rail directly to the bandsaw table. And this was done by mounting the rail directly to the miter bar slot on the bandsaw. And what I did is I took some inserts to fit in the miter bar slot, and I had to re-drill the holes to move them slightly. And these slide in the miter bar slot, and then the rail screws to that, and the Accu-Slice system slides on that. And this system worked good except for two issues. Number one, it's kind of limited to the Laguna bandsaw, the 14-inch bandsaw, and maybe a few other bandsaws. But everybody's bandsaw is slightly different. The distance between the bandsaw blade and the miter bar slot varies between probably 3 inches up to maybe 7 inches. So that variation won't work with this technique. This will only work on the Laguna bandsaw and one or two other manufacturers of bandsaws. The other issue, in order to use this, I had to take my dust shield off my Accu-Slice system because it was too long. So that would require designing and making a different dust shield to get it lower. But that can be done. That's no major issue. The major issue is making this universal so it fits to different manufacturers of bandsaws. So my thought was, well, what's the difference between this and my standard Accu-Slice system? And that's the plate. There's a 1/4 inch thick plate on the Accu-Slice system. So my next design idea was to take a standard plate. This is a piece of aluminum, 6 inches wide by 12 inches long. And I made some new inserts to go in the miter bar slot. And this is screwed to those inserts. And then I have holes drilled in the plate to mount my rail. So this plate gets positioned on there, and then the screws get tightened to lock the plate in place. And then I have holes drilled in this plate that I mount my rail. So with this technique, my rail is the same height as on my Accu-Slice system. So as a result, I can use my Accu-Wedge with the dust shield installed. So my standard dust shield will now go back on here, and it'll work quite nicely. And this plate is extra wide so that I can modify the mounting holes for different size bandsaws. So in the case of Laguna, they're fixed, the plates mounted here. On the Rikon, the holes for the plate would be mounted way out here, like 6 inches away. And so and different manufacturers require drilling at different holes in different positions. So it'd be custom fit to the individual bandsaws, but it can be set up to run those different size bandsaws. So that solves the one issue of using this for different manufacturers of bandsaws. But then I was thinking of what is a better way to shield these roller bearings from sawdust. Because one of the major issues with the Accu-Wedge system is these bearings get clogged up with sawdust quite easily. If there's no dust shield, they get clogged up real quickly. With the dust shield, after you cut maybe 50 wedges, you got to pull this off and just wipe these bearings down to get rid of the sawdust. But is there a better way to shield these bearings? So my thought is to get this plate and actually move it over 1 inch and create a dust shield and mount it to the plate. And the dust shield may look something like this, like a brush, or it may be aluminum angle iron mounted to that plate, or maybe a plastic angle iron. So I'll be looking at different options to create a better dust shield. And maybe it's 2 dust shields. Maybe it's one mounted on this plate and one mounted to the Accu-Wedge, so they're like overlapping systems, and that would definitely keep the bearings a lot cleaner. So in this video, I'm going to be building and designing a couple different prototypes, testing the design out, see if we can come up with a commercial system that we can market to use the Accu-Wedge without the Accu-Slice system. Since I have a new CNC mill, I can easily machine these parts and do some testing. So it's easy for me to do my testing and development now. And I can also manufacture these as it's needed for customer needs. So that'll be this video, designing and building and testing some prototype versions of the new Accu-Wedge mounted directly to the bandsaw table. On the standard Accu-Wedge system, on the bottom plate, we have the roller bearings mounted, and these are actually mounted on standoffs that raise these roller bearings about 1 inch below this plate. And that was needed because on the Accu-Slice system, this plate has to ride above the mag jig clamps, and that's why those spacers are put in there. Well, with this system, we don't have any mag jig clamps. So as a result, I can remove these spacers. By removing these spacers, my roller bearings will be lower to the plate. By being lower in the bandsaw, it should be more stable, a little more accurate, maybe a little less vibration. Should give you better cuts. So that'll be another study I'll be doing, is removing these spacers, lowering the plate, of course making a new dust shield to shield the roller bearings, and seeing if it improves the operation of the system even further. And all these changes, making a new plate, getting rid of these spacers, making a new dust shield, should improve the operation of the Accu-Wedge system. So we'll be describing all that in this video, and I'll be showing you how I make these various parts on my new CNC mill. I just drew up the plate to get the dimensions. So I have my 3 holes drilled for the to mount the rail, and then I actually designed it to fit various models of bandsaws that I know. Like I know the Rikon. Again, look at the distance between the bandsaw blade and the distance needed for the Accu-Slice system. And in the case of the Rikon, it's 6.1 inches. For the Powermatic and one of the Grizzlies, it's 4.5. For the Laguna, it's 3.5. So I actually have a Rikon that I'll be using trying this on. So I'm going to drill my plate with 2 holes, one for the Laguna and another set for the Rikon. So I have my software program I'm working on, and I'm actually using 3 tools. My first tool is a drill, which is 0.201. This hole will be for the 3 holes for the rail, and then I have 4 holes for the Laguna and Rikon bandsaws, and then my third tool is the countersink for those holes, because it needs a countersink so that the rail goes on. So let me work on this program. I have it all set up. I have my 3 tools set up: tool 7, tool 8, and tool 16. And then I'm drilling the holes to the correct depth required for this project. So it's a pretty simple program, and I can show the graph how it actually is going to look when it's done. And this is the 3-dimensional graph. I got my 3 holes here for the rail, and then my 2 sets of holes. This set of holes for Laguna, and this set of holes for the Rikon. And if I was doing this plate for other bandsaws, I'd be drilling other holes in here. And what I'm showing here is the holes, and this wider portion is the countersink for those holes. So let me go and start machining this. Post the program. And we're ready to start machining. This first set of 3 holes we're drilling here are the 3 pilot holes to mount the rail. So drill with a drill, which will later be tapped in order to attach the rail to the plate. Next, I changed the drill to a larger drill. This is a 1/4 inch diameter drill, in which I'll be drilling the 4 holes to mount the plate to the miter bar slot. I'm not showing it here in this video, but I also machined the miter bar inserts for this project using the same CNC mill. I then changed the drill bit to an 82-degree countersink bit, which will be used to countersink the holes, which will be used to attach some flathead screws to attach this plate to the miter bar slot. Next I want to attach this brush dust shield to the top of the plate. So I used some small clamps to clamp it to the plate and then drilled 3 holes through both the dust shield piece and the plate, which will later be tapped to hold the dust shield in place. So this is the resulting plate, and I have holes drilled here to mount the rail. There's 3 holes to mount the rail. These holes are for the to screw into the miter bar slots, and these front ones here are for the Laguna bandsaw, which is 3.5 inches from the bandsaw blade, and these are for the Rikon, which is 6.1 inches from the bandsaw blade. So this system is set up for 2 systems, and for other bandsaws we have to drill other holes. Now in addition, I put this brush on the system. This brush goes between the blade and the roller bearings on the Accu-Wedge. So, and this surface of this brush rides against the bottom of the Accu-Wedge carriage, so it should keep the bearings clean. So we'll give it a try and see how it works. The other part is these inserts that go into the miter bar slot. These are T-slot inserts. So this won't work on a bandsaw. It doesn't have the T-slot inserts. You have to have the T-slot inserts to hold it in place. So they slide in, and then it screws into these countersunk holes using 2 flathead screws. And then it's going to be slid until you lock it in place. When you get it where you want it, center of the table, then we can lock it in place. And the rail goes on. Again, center the rail. And I'm just using 2 screws. I think that's all you need is 2 screws. You could use 3 if you want it, but because there's holes for 3, but I'm just using 2. Stop here. And my ramp. Ramp's probably the wrong height now, it's just the ramp. And then my carriage has the low spacers, so it's much lower on the bandsaw table. And you can see that brush is right against the bottom of the table. Actually rides on the brush. Carriage should always slide, that they don't stick, but you should, when you do that, it should stop. You don't want it to slide continuously. So you don't want a lot of friction, you want it to move. So I see my ramp is too high now, so I have to move that down. Okay, let's cut some wedges and test it out again. Again, I'm cutting 18 segments per wedge, and now my Accu-stop is too high. To make a new Accu-stop because it's too low. You're actually drilling another hole. Since the Accu-Wedge now rides lower on the bandsaw table, it no longer lines up with the Accu-stop. Therefore, I'm just using the flat plate on the Accu-stop for alignment. Okay, let's just cut wedges, see how it comes out. This video is shown at 5 times the actual cutting speed, just for viewing purposes. But in reality, the slower you cut, the better your cuts on your segmented pieces. And I'm using the plate on the Accu-stop to set the segment length. So I first cut about 15 segments on this piece of walnut wood, and then switched to a piece of tiger wood I had and cut another 15 wedges. It wasn't enough to make 2 complete discs, but I'd be able to make 1 disc out of all these pieces. So that wasn't enough wood there to make a project. But I mainly wanted to check, see how the sawdust is getting in here. And I see the sawdust all over the top of my Accu-Wedge. A little bit in the channel here. A little bit between this brush and the miter slot. So that sawdust still manages to get in. But it's pretty good. Most of the sawdust is on the other side. Let me move the camera so I can show it a little bit better. So you can see the sawdust is down in here. There's very little in here. There is some. So it's still going to get in your bearings, but not as bad as it was before. Well, that system worked okay, and I did assemble those segmented pieces I just cut and put together a segmented disc, which is near perfect. Came out really good. But I have to make a new Accu-Stop, and I'd have to have two models of the Accu-Wedge, which probably doesn't make sense. So I think we're going to go back to the original design. There was no difference in performance. You know, the wedges were just as smooth as the previous model. But what I do have, I have a taller brush, because this rides up higher. This brush is about 3/8 of an inch taller. So you put that in here. And so what I have here, I'd have the brush, you know, keeping the sawdust out of the bottom, and my dust shield keeping it from the top. So actually using two shields may actually be better. And I don't have a taller brush. I actually can use a brush that's about 1/2 an inch taller. I'll see if I can get a taller brush. I don't know if they make one or not, but I'll see. Or I could use a piece of angle iron, a little bit taller. But that would be a double shield for the bearing, so that actually might be good. So let me give this a try, see how that works, see how the sawdust builds up. Well, I reinstalled the taller bushings on my roller bearings, and I put a taller brush on my sled here, or my plate here, and I reinstalled the dust shield back on my Accu-Wedge. So now I have two layers of dust protection, one from the bottom and one from the top. So that should work pretty good. Actually should be better. So now I have this piece of cherry. I can make quite a few segments from this. Again, 18 segments per layer. 18. Let's make a bunch of segments, and then we'll assemble some discs and check for the sawdust buildup and see how it's going here. Well, it was 36 segments cut on here, and I see no difference in the smoothness of the cut versus, you know, up high versus low. So there's no difference at all. I thought it might improve it going lower, but it doesn't. But let's check the bearings and the sawdust channel. Bearings are clean, they look good. Sawdust, most of the sawdust is on this side of the dust shield. A little bit on this side, and a little bit on this edge, which it appears to be just going over the top. You know, when I pull the sled back, you see there's a lot of sawdust on top of the sled here, and some of that's flowing into there. But it's not flowing in this way as you're cutting. And it's keeping the bearings much cleaner, and the channel is cleaner too. Well, let me sand these and we'll assemble them and see what they look like. Well, these are the two cherry segment rings I just cut, and I sanded them, sanded off the fuzzies and the burrs, and I got two nice wedges, you know, perfect wedges, nice tight joints. And then previously on the lower system I made this segmented disc, which is fine also. So this concludes this video on some studies on the design of a new version of the Accu-Wedge. I tried a couple of different things. Number one, I made a plate here that the rail mounts to. It has a dust guide included in it. And I tried the lower wedge by putting the lower spacers on between the roller bearings and the plate. And that worked fine. There was probably no difference. The main difference is it would mean having two models of the Accu-Wedge and two models of the Accu-Stop, and that just raises cost of manufacturing. So it'd be better to stay with the standard version, which we're going to do with the standard Accu-Stop. And the addition will be this this adaptation plate, which you can use without using the Accu-Slice system. So again, this mounts on the miter bar in the bandsaw. Has a 1/4 inch thick plate, which the rail mounts onto, and this plate mounts into the miter bar with some miter bar spacers, T-slots, and this brush on it, which gives you a dual dust collector, which seems to help, but I think you get more dust coming over the top than you do going through it. So this will be a new model. You'll probably see it on the website in a few weeks after I get some material ordered, because I got to make these plates, and I have to make the parts for the slot in the bandsaw table, the miter bar slot. So I'll be working on that, and we'll have a new version of this that people can use on the bandsaw without using the Accu-Slice system. People also ask about using this on the table saw, and we do not sell it for the table saw. If somebody asked what to buy for table saw, I wouldn't sell it to them. It'd be just too dangerous. The fact that you're above the table here for the system, and you're cutting boards, cutting at an angle on a table saw, they're liable to go flying on you. So it'd be too dangerous. So we do not recommend at all using this on a table saw. It's strictly designed for a bandsaw. And the bandsaw has the advantage too that the kerf on the bandsaw blade is only about 50,000th of an inch, where a table saw is 1/8 of an inch. So you lose a lot less wood by using the bandsaw versus a table saw. So once again, thank you for watching this video. If you have any questions or comments or concerns, please give me a call or drop us an email. We're always happy to talk with you, and always looking for new ideas and new designs. I mean, this came about because a customer called me and asked, can I get a system without having to buy the Accu-Slice system? It's too much money to buy the Accu-Slice system. Although it's very versatile, offer a lot of other options. Now we'll have a version which is lower cost to sell this to more people. So once again, thank you for watching this video.